So here are the materials. Let's first start with some linear guides over here. Those are just the cheapest ones I could find off Amazon with some additional end stops. I've got practice with these in my CNC machine, and they are for the sliding table. So when I cut pieces of aluminum, I can fixture to the table, which is made out of these profiles here, and there I get an accurate cut and close to the dimensions I need for milling. Still missing is the aluminum profile for the frame. I've got 80/80 extrusion in light because I need to put some screws in it, through it in lengthwise. For today we're gonna build the wheels. For that I've got some multiplex from just from Obi. This is 60/60 aluminum. Normally I've only milled 50/83. You can see here it's plain ground, or not ground but milled with a really large fly cutter. This one here is just hot rolled. I don't know if you can see it. The finish is beautiful. I thought on the website that it would be worse, but it's really going great. I'm not gonna face it just because it's 10mm aluminum. The flatness is not gonna matter really much, and yeah, the finish is already very good. But it's gonna be a new experience because this material is like specially made for milling. It's from HC Maschinentechnik. All my cutters as well. It works wonderful for learning, but the price is rather high. So I've got like I don't know. I've got 3 1 meter pieces here, and they were like half the price the equivalent would be in 50/83 aluminum. So new learning experience here. I need to cut bearing seats into this, like here. These bearings will be for the wheels and run on this shaft. This is 500mm. I will need to cut it in half. That's gonna be interesting, but Amazon didn't get a better offer on this, because otherwise I would have to pay shipping twice for 2 smaller pieces, and well, I fancy the challenge. This is gonna be held by some holders, actually. So I don't need to mill the clamping device. It would probably have worked, but they were so cheap. They were on a discount when I ordered, so I just picked them up. They were perfectly there. Also from HC Maschinentechnik. I really fancy it. Half a turn on them and it's completely tight. Half a turn on them out, and it's perfect sliding fit. Work really nice. Also, you can kind of see it in the back here. It's gonna be powered by an HDD 5M belt. I've ordered this. This is actually for e-scooters, and just off Amazon. It's okay. And I'm gonna try to print the pulleys. This is gonna be the motor pulley. I don't know if I will use this in the final product, as I can get it out of aluminum, but I'm gonna need like I believe 100 tooth pulley sitting on the wheel going around the bearing houses, and there's no way I'm gonna get that somewhere, so I'm gonna have to print it I don't know what material I'm gonna use yet, but that will need to be the final product. And this is a parametric design got of GrabCAD. I'm gonna try to link it below, and it works wonderful. I mean, I've just given a number of teeth I want, and this is right in there. Next up for the wheels is these bandages, I believe in English. They are what's going around the wheel. I don't know if you can see it. It's just a large rubber band with here a bond. I would have expected it. I ordered these I did a special offer on these at Buchhaupt in Germany. Here they offer huge variety for commercial bandsaws, but I let these be made specially for me because it's a relatively small diameter, but extremely thick for aluminum blades, which I hope I can get. I would have expected these to be better, but yeah, this was 40 euros for 2 large rubber bands. I don't know if I would do that again, but they're gonna be more wear-proof than anything I could have made myself, and I hope it's worth in the long run. So the plan for this video is to cut the wheels out of the multiplex, then cut 4 wheels. I'm gonna sandwich 2 of them each, top and bottom, and then 4 additional bearing houses out of this new material. First thing I want to cut is a bearing house. It may not be that smart, but we're gonna figure it out. And yeah, then we're gonna cut it out, screw it together. Here I've got some rather nice bolts actually. Another thing that's gonna be interesting is this shop is made in an old builder's wagon. And this is actually just a look around. It's not that tall, and just getting the machine base for the bandsaw in here is gonna be quite tricky. It's, especially like the large pieces. I can barely put them through the machine and get them to the back here. It's gonna be quite tight, but I think it's gonna work. Now about the set machine. This has a work envelope of about 170 millimeters in Z, about 500 in X and 450 in Y, and I can just pull through in Y, so it's gonna be good at machining these large pieces. I've got the AMB spindle on it, goes up to 25,000 RPM, which is surprisingly great for cutting wood. I've got great experience with it. It's so much nicer than some China spindles, because I can trust it actually. Large, like I've done some gift engraving jobs, and just having the trust in it that it can run at 25,000 RPM for an hour and a half, maybe 2 hours, is so much greater than having like a 2.2 kilowatt spindle that might go quicker through some aluminum, but in the long run it's gonna overheat or cause other problems. So great recommendation. It works really well. And 10 millimeter. Yeah, I've actually shortened it. It's I might go to jail for that. I'm sorry. It's an insert cutter. I don't know if you focus. This is 10 millimeter diameter, and I can really push it with the spindle. It's surprisingly good. This is like for roughing, so I can just switch out the inserts if I have a dull one, which until now hasn't happened. So here we have the setup. I've just used my one like parallel here as an alignment, so I only have to dial in the x-axis one time. It's like here. Oops. It has the same key, I would say, in it, so it locks into the T-slot table, and it's repeatable within like 2, maybe 300. It's actually surprisingly good. Of course, me pushing it against it is not gonna be that good, but running an indicator along is very well actually. In case you're asking, yes, this is Lego. Before milling, I was a Lego enthusiast. I mean, I still am, but I don't practice it anymore. This is for my phone. Bonk. Now I can dial you guys in. And I've fixed it to this table instead of this one, because I've made bad experiences with mounting mounting the camera to Mr. Shaky machine here. It's not good. That's gonna be the program. I've got like a TV up here, and I've actually got quite a nice cutter for this one. I don't know if you can focus. It's brand new, just with DLC coating. I forgot to turn on the dust collection. And instead of turning off the Cincy program, I turned off the camera. I don't know what it is then. Tight, but this is 8.5. I want to put 8mm bolts through, and that's perfectly okay. that's gonna get turned off later when I spin it and try to wood turn it. And see how that goes. So, here we have the setup. First operation will be drilling. Here with the new coated drill. Mimic the bolt pattern on the wood wheels. They're still drying back there. Second one will be roughing out the main pocket. with the big, also coated 8mm single flute. That'll get the internals out. I need to go up to 32mm bore for the bearings. I'll have 0.2mm left after this one. And for finishing, I actually have one just for finishing. If you can focus. It's 3 flutes, uncoated, for a sharper edge, I believe. And first on all 4, I'm gonna do all 4 at once if I hadn't said that. It'll do all 4 of them to nominal size, and then I got CNC programs for 0.01, 0.02, 0.03 oversize for every single hole. So I'll finish all with this one, and then I'll use the bearing as a gauge to try and fit it in, and if it doesn't on hole 1, I'm gonna load hole 1 plus 0.01, try it again, until it fits. I'm gonna rather be a little bit on the undersized side instead of oversized. So this is aluminum, the bearing of course is steel, so if I'm a little under, I can heat shrink it in, and I'll have a play-free system rather than going oversized and messing it up. This is the first time I'm gonna cut bearing seats, and this is the first time I'm gonna cut this material. We'll see how it goes. I hope everything's gonna go alright, but we'll see. I've used this cutter a lot. I've actually chipped it here, if you can see it, while hammering it out of the broken collet I mentioned. It's gonna be okay for roughing out. It's enough stock to leave for good finishing, but I do know the cutting values I would use in this on my 5083 aluminum. I've tuned the radial engagement down like a bit, so it's a bit less aggressive, but I know this should work, so I hope I get a bit more success than in Op 1.
There we go, it's perfect.
gonna go in if I wanted to.
That's perfect!
Okay, now last operation will be the contour to cut these out. It's with a quite thin single flute because I wanted to get the diameter as big as possible. So the line in the middle here is I believe 5 millimeters, and this is 8th inch cutter. The cutouts will be without tabs, so I fixtured the single cups to the spoilboard with these Linsenkopfschrauben, I believe buttonhead in English. They've got a square underside, so when you pull them down, it doesn't move the piece. With normal wood screws, if the contour is finished, it might move the pieces a bit and cause problems. These shouldn't do that. Okay, sorry, the camera ran out. I've just drilled all of the holes. I'm sure you can guess how that went. Then I'm just gonna chamfer them and then we're done with these parts, I guess. Okay, now we're up for assembly. Hope you can see everything. It's a new camera angle I'm trying here. That should work. Bearing seats will be bolted down here in a second. I love this workflow with just grabbing stuff out of the infinity board I have in the cupboard and getting it on here. I've got normal bolts and these are stainless steel, so just they were that much more expensive, so I just grabbed them. It's not gonna make a big difference, but I have to do this twice, so it's worth to get them out. Get them straight. It's still so cool. Now for the stakes. I wanna first use just 3 bolts, level it by, I don't know if you can focus it. Yes, I'm gonna level it. I'm turning the light down a bit so you can see better. I'll have it like this and on the shaft, and then wiggling it to the side a bit to get this face running through with the rotation of axis. But this is 8mm, right? Yep. There's some wood glue that's zipped in. You can see halfway through. I don't know if you can see it, but these marks in the table, I always just take them for dirt and try to clean them up, but they're not moving. So now, number 2. really loose at this point. Did you really just have to watch me do that without grease? Yeah, well, figured it out. Some grease helped a lot. I've also got this block here with one blind hole and one through hole, which I used actually like a bearing puller with just banging this on the shaft. And well, both are in now. I need to like axially fix them now. There's super helpful M10 hole in the end, and I actually have the perfect thing for the other side. Just need a spacer and so I've got it dialed in now to within 0.2 of a millimeter, which is totally fine because this is definitely no gauge surface. Every time you switch from here to here, this is multiplex wood. It's far from parallel. There's at least like a 0.2 in parallelity error in it, so this should be fine here. It's okay. This isn't the used surface. This will be what's used later. So, a day later, all bolts are torqued now with 9 newtons. It's just an even number. The outside has been turned. It's a really nice surface. It was quite an improvised setup. We've had the shaft mounted to the T-table. Then with a drill we spun it and had another shaft on the T-table, and with a wooden chisel, with a chisel for wood, we turned the outside and sanded it a bit. There's still like 3-4 tenths of a millimeter in run out. It's gonna be okay, I hope. But this is finished now. This the bolts. None of this is gonna move. And now for balancing, I've thought of this setup. Because when you would do it with the shaft, first off, these are the cheapest bearings of Amazon. They're not going to turn freely enough, and you'd have to align it axially. You'd have to level it perfectly in order to get a proper reading. Now, between I've got the band here. Now, if I put it somewhere. It does the thing! What I want. Now I know the heavy spot. I'm gonna let it fully settle. Then I'm gonna mark the opposite side, drill and put a screw in, because the screw is heavier than the wood. And thereby I don't have holes in the final product, but rather screws that should prevent dust buildup. So the work I'm doing is final, and not while working the holes are gonna fill up with dust and it's gonna be unlevel again, unbalanced. Okay, now I don't know if you can see that. There's 2 on each side in now, and it's quite good. But the bearing is there's just too much resistance. So I'm gonna if you can see the points here. There's 2 marks, one here, and those are made by, I'll leave it on this side of the heavy point. The heavy point is actually here, but I'm gonna mark the other side. Then I'll wait till it's settled. Let's say it's settled here now. Make a mark here. Then, because I know there's a lot of resistance in the thing, I'm not gonna just drill here and put a screw in, but I know it's somewhere further along. So I take the other side, wait, like at this point it's 2 minutes till it's really where it wants to be. Now here, another mark, and now I'm gonna put it's quite good, so I'm gonna put a smaller screw in the middle now.
So, it's done. I've got 2 wheels now, both running true on the outside, kind of on this side. They're balanced. This one actually only needed 1 screw. The other one needed 6, you can see. And yeah, I'm looking forward to it. These bandages I ordered are still a bit tight, but it's gonna work out. If you wanna join me on the journey to building the machine around them, you can subscribe to the YouTube channel. I don't know, it's probably gonna be a lot more of this coming, but I'm really happy with the first milestone, getting these done. They're going on the shelf now, and yeah, I'm waiting for the aluminium profiles. See you in the next one.